We got an electron here. We're going to have to reverse things, right? So it's traveling. There's a southerly electric field, right? So let's draw a picture of it, right? A southerly electric field is literally, if the electric field is to the south, the electric force on an electron, right, is going to be EQ. And so an electric field to the south times a negative charge is actually a force to the north. Okay? So the electric force, if there's a southerly electric field, the electron is going to be forced to the north. Therefore, our magnetic force has to be to the south. Okay? Okay, so we do know that, right? We're going to have a southerly magnetic force. Okay, let's see. And then we also know that the magnetic field is vertically downward. So we know the B is into this page. Right? Vertically downward on a map problem is into that page. Okay? So vertically downward. So let's figure out the direction of the velocity. Now, this is tricky as heck. Okay, so our thumb, let's put our middle fingers into the page, right? We need a force that's south, right? So my middle finger is into the page. My thumb is pointing down the page. My index finger is pointing to the west, which is correct for a positive particle, but a negative particle would have to go to the east. Okay, so it's going to be east is our direction. Oh my God, that's so complicated. Okay, I think I can do this though. And then of course we want to find the velocity, so we're going to say QVB is EQ. The Q's the Q's cancel, and then the velocity is just going to be E divided by B. Right, so that's going to be 3.8 times 10 to the 5th newtons per coulomb, and then that's divided by 0.287 Tesla, and somehow that's meters per second. Somehow that's meters per second. How is that meters per second? There must be a way for it to work. Okay. That's Tesla. All right, so let's just get the number here. We won't worry about that. I'll go on a rant. 3.8 E5 divided by 0.287. Oops. 287. Well, that's just a big unhelpful number. So I'm getting that it's 1324041.812. So let's see, 1, 2, 3, 4, 5, 6, so 1.32 times 10 to the 6th meters per second, and it's going to be to the east. All right. How is newtons per coulomb over Tesla's voltage? Please stop watching this. I'll do the rest of these in the next video, okay? How is it possible? How is a newton per coulomb divided by a Tesla? How is that meters per second? Okay, what is a Tesla? A Tesla is, well, let's see, it's ILB, so it's newtons divided by amps times meters. It's a newton over an amp meter, right? Because force is ILB, so therefore B is F over IL. So I would be amps, L would be meters, right? So let's do that. We can do it. So that is a newton per coulomb divided by, so multiplied by amp meters over newtons. Okay, that's easy, right? The newtons go away. And now we've got an amp is the same as a coulomb per second, right? So we've got coulomb per seconds times meters divided by coulombs. We end up with meters per second. All right, there you go. Hope you enjoyed that rant. I bet, did anybody watch that? Here's a secret word, rumple pooper skin. If you have so little to do in your life that you actually watch that, just come up to me and just say rumple pooper skin. I'll have no idea what you're talking about, but it'd be funny. All right.